Good morning. Oh, thanks, Vaibhav. Sharath, are you also on with the proposal that I have given? Sharath, are you there?
Yes, sir. Yes, sir. One second.
You agree with the proposal?
Yes, sir. I'll do.
Oh, okay. I'm waiting. I'm waiting for Jatin, Mrityunjay, Navneet, Sharath, Vaibhav, and Sharath are there. Ayush, Rajesh, Prabhav Jain, Shashmita. Shashmita has a difficulty. Aditya, Gaurav, Pramod, and Sriraj. Thanks, folks. Some of you are now with camera on. Sriraj?
Yes, sir, I'm trying to.
You're trying. All right. Okay, folks. Now, would you have any quest ions transporting in your mind? Do you have any quest ions transport in your mind? No response. Are these ions transporting in your mind? What? Yes or no? Is everything clear? Questions you may have? What, Aditya? Do you have any ions floating in your mind? No. All right. Okay. Now, let me start with uh, we had discussed about strength of a material or failure of material in the last couple of classes. So I'll just shift to one more aspect on stresses before going to strains. Okay. So I'm going to ask you this question. So let us have let's say a two-dimensional stress plate of this kind. What kind of stress state is this? What kind of stress state is this? Sharad, Sriraj, Aditya, Vaibhav, Megha is not seen in the videos. Yeah, go ahead, go ahead. I'm waiting. Sriraj, are you there? Sharad, are you there? Aditya, I have no answer from any of you. What's the point then? Are you interacting with me? Hello? Are you interacting? Yes or no? You have to say no.
Yes, sir. Yes, sir.
Yeah, if you're interacting, I'm
Yes, sir.
asking you one simple question here. What kind of stress is this? What kind of stress state is this? What do you know by seeing this? What do you infer from this? What do you infer from this? Please be with me, else there is no point here. I mean, why should I go through all this nonsense? See, look at you. Just five of you are there in the video. In spite of asking, I'm not going to entertain anybody else other than those who are in the video. Right?
There is a,
Vaishnavi, are you on the video? No. Tell me,
there's a stress along one of those axes.
what do you call that kind of stress state?
One-dimensional stress.
One dimensional. Give me another word for it.
Tensile.
Another word for it. Sriraj.
Normal.
Longitudinal.
It starts with a U.
Uniform.
Where does uniform come in here? Yeah. I'm not talking about anything. U for unity, U for uniform. So many things are there, but I'm asking about this. And it starts with the letter which has with a word that has a letter that starts with U. UN.
Unidirectional.
AX.
Uniaxial.
Uniaxial. This is uniaxial state of stress, right? Okay. Uniaxial state of stress, one dimensional, right? One of you said one dimensional. Fine. Okay. Now let's say I'm going to transform this. Are you people with me? Because the response that you're giving me is very lukewarm. Will this continue the same way? No. Aditya, are you there
Yes.
physically and mentally present here? Sriraj,
Yes,
are you
sir.
mentally present here? I can't hear you.
Yes, sir.
Please, yeah. Else, just put off the camera. There's no point. If you're there, please be there mentally and physically. Vaibhav, are you there?
Yes, sir.
All right. Okay. Now, supposing I transform this, okay, so let's say there is a particular axis along with I have found this out. Okay. Let's say there is some other axis that I take. What will this transform to? This will transform to something like this. Yes or no?
Yes.
Yeah. So let me just put it as prime here so that, okay, this is x, this is x prime. Okay. Now, will this value be present? Possibly yes.
Yes.
Will this value be present?
Yes.
No.
Yes. How about this value?
Mm, possible, yes.
Possible yes. Correct? Yes, Aditya.
Yes, sir.
All right. So, having done this, let's say it is a fully populated matrix, right? How do I know this is uniaxial? Do you understand my question?
Yes, sir.
You looked at this and said it is uniaxial. What is this? Uniaxial stress state, right? This is uniaxial stress state. Okay, are you with me? Are you with me?
Yes, sir.
Yes, sir.
All right. Now I transformed it and got another matrix of the stress state, and it is fully populated. All the values are available. Now I ask you the same question. Is this uniaxial state of stress? Do you get my question? What would be your answer?
It would still be uniaxial itself, but then
If any of you want to answer, have your video on and answer. Okay. So let me see if it's okay if even the others want to do it, but have your video on, then I'll take your answer. Yes. Go ahead.
it would still remain uniaxial itself, but not
It
along
will
the
still remain uniaxial. Exactly, Sharath. Yes, it has to be uniaxial. So how would I now ask? I'm going to rephrase the question. How would I know, given a matrix of the stress state, how would I know whether it is uniaxial? Mohammed, Janisha, all those who are chatting, you should have your camera on and then speak voice over. How do I know, given a matrix, So the question is now reframed. Given a matrix of the stress state, how do I know this is uniaxial stress state? I'm not going to entertain chat today. Let me see how it goes. Only over the voice. Okay, Sriraj, Aditya, Vaibhav is hiding. Ah, you're there. Yeah. Sharat. Mohammed, I'm not taking your chat unless you come on video. Same with Anirudh, Ayush, Raghu, Janisha. I'm not going to come on that chat. I'm not going to see the chat. You have to come on video in order to answer. Yeah, go ahead. The
Uniaxial
question has been asked.
because if there is on either only sigma x or sigma y, not both.
This is not uniaxial then?
Yeah, yes.
This is fully populated. All the values are available. Come on. I think
Sir,
there is a paucity. Yes, Mohammed. Mohammed, I can see only your head.
sir, someone's behind me. Sir.
Doesn't matter here. Someone can be behind you. Okay.
Sir,
Don't hesitate. It's okay if people are moving around in the back. Yeah, go ahead, Mohammed.
is the determinant 0?
No, yeah. Determinant is 0 is fine, but give me a different answer. See, listen to me very carefully. We started with this. Okay. This matrix consists of what kind of stresses? It consists of what kind of stresses? We discussed transformations and all those, no? Starts with the P.
Principal stress.
Principal stresses. This is a principal stress, this is a principal stress. Is it not? The moment I have zeros here, it means that in the Mohr circle, I am on the axis. Yes or no? Yeah? In the Mohr circle, I'm on the axis of sigma tau plane. Right? So these automatically become principal axis. I transform it, I get something like this. Okay. So in the circle, it is like this. I'm somewhere here. Okay. All the values are available. There is this value which is sigma x, sigma y, and tau xy. All the values are non-zero. Now I asked the question whether this is uniaxial. You said yes. Right? Why did he say that? Because you saw this one. So I'm asking you this question now. Given the matrix of a state, how will you know or identify it to be uniaxial? That's the question I'm asking. Very simple question. Very simple question. Hey, again, I'm going to ask you this question here. Don't mistake me. I'm again asking Sharat, Sriraj, Vaibhav, and Aditya. Are you mentally present in the class?
Yeah, yes, sir.
Yes, sir.
Then just think along these lines and answer. We went forward from this stress state, this matrix of the stress state to this, and looked at this as is populated. Now, if I give you a populated matrix and I ask you that question, okay, this is the matrix for a two-dimensional stress state. I now want to find out whether it is uniaxial stress state or not. A very simple question that I'm asking. Logically, very simple. Did you understand the first part? Yeah. From the first part, can you answer this question? Can you answer that question? Chaitanya, again, I am not going to look at chat. You have to come on video and answer. This was going to take me 1 minute before going into any other concept here. I mean, and you're just waiting. Do we have an issue, problem? Do you know what is stress transformation? Yeah.
Sir, are we supposed to transform the matrix then? Sir,
Okay. You're inching towards it, towards the answer. How would I find out? How do I identify it as uniaxial stress state?
Is the transpose of the matrix same as the existing matrix?
Can't hear you. Is the
If the transpose of the existing matrix is same as the original matrix?
no, transpose is always the same. It's a symmetric matrix. Always a symmetric matrix. There's a symmetric matrix. There's a symmetric matrix. All the stress matrices are symmetric because we used a moment equilibrium principle to show that tau xy is equal to tau x. But my question is this matrix a uniaxial stress state? You said yes by saying, okay, it belongs to the same matrix as this, and this matrix has only one principal stress non-zero, the other is zero. Now I'm asking a different question here, which is related to what we discussed, but in the reverse logic, given the matrix of a stress state, how will you identify it to be an uniaxial stress state? A very simple question I'm asking.
transform the matrix at top becomes 0 and then see if sigma y.
What do you call that process as? You're right. You transform this matrix so that it becomes what kind of matrix?
Diagonalize
Okay, what do the diagonal elements represent?
Stresses.
the stresses. The uniaxial stress.
Diagonal of the transformed diagonalized matrix consists of what stresses?
Principal stresses.
Oh, it takes such a long time, huh? It consists of principal stresses. When I look at principal stresses, can I identify it to be uniaxial? Yes. Now answer this question. How do I now do this? How do I answer this question now? I'm giving you a matrix.
Find the
Yeah.
diagonal matrix.
Find the or diagonalize the matrix and find, or in other words, find what? What stresses?
Principal
Principal stress.
Principal stresses pertaining to this matrix. And
If only one of them exists.
if only one of them is non-zero, then it is a uniaxial stress state. Fantastic. All right. Now, let me extend the question. Supposing this is sigma 1, sigma 2. Okay. Now, both the axes, X and Y, have stresses in it. We'll call that as a biaxial stress state. Yeah. Okay. So if it is fully populated and I diagonalize, I get to be two different values of sigma 1 and sigma 2. I call it as a biaxial state of stress. Okay. So let me extend this to 3 dimensions. Let me extend it to 3 dimensions. So I'm going to now make it into 0, 0, 0, 0, 0, 0. And I ask the same question. Let's say this is transformed. I have some matrix, okay, which has sigma x, tau xy, tau y, xz. Symmetric anyways. So sigma y, sigma z, tau Y, Z. I have this matrix. Okay. All right. I'm given this matrix. Okay. I transformed it. I got it to be this way. Okay. So what do I know about this matrix?
Triaxial.
Look at this here.
Uniaxial.
This matrix here pertains to a uniaxial state of stress if this has transformed to this. Correct? On the other hand, if it is like this, sigma 1 and sigma 2, then
Biaxial.
this matrix is biaxial.
Biaxial.
If I have all the three of them present, it is
Triaxial.
general
Triaxial.
state of stress. Right? Triaxial, you don't have fourth axial axis anyway, so it is a general state of stress. All right. Now, if sigma 1 as well as sigma 2, okay, if sigma 1 is equal to sigma 2, that is, I have sigma, then this is 0. Then
Still biaxial.
still biaxial. Fantastic. Still biaxial. Supposing this also is sigma, then
General.
give me some other understanding. Yes, Aditya. Give me some other understanding. Others also can come in. I mean, the three groups consisted of 12 people. There are only 4 of you, 5 of you over here. Unfortunately. Yeah. All the three principal stresses are the same. What do you conclude? This pertains to what kind of stress state?
So triaxial.
Bulk stress.
Hydrostatic stress condition.
Hydrostatic. This is hydrostatic. Hydrostatic state of stress. Okay. Whatever transformation I do on this, what will happen? Whatever transformation I'll have on this, I'll get a 0 here and 0 here. You can try it out. Okay. So why am I calling it hydrostatic stress? Because it doesn't matter whether I have, let's say, water in a beaker. I take a small volume over here. Whether I take it in the x direction like this or like this at the same, let's say at the same depth or x prime, I'll get the same matrix. I'll get the same matrix. All right. That's the beauty of all the three being equal. All right. In a uniaxial, in a biaxial state, if you draw the Mohr circle will be a, supposing it is just biaxial stress state and I have sigma. What do you know about the Mohr circle?
A point.
It will be a point, which means only Janisha has done the assignment. What, Sharath, Sriraj, Vaibhav, Aditya, you've not done the assignment yet? What is this
Yes.
here? I'm getting bugged by all this, really. Would you
Yes, sir,
need
I
a,
have done.
if done means what will I get if just sigma in the biaxial state? What will I get as Mohr
Only a
circle?
point.
It will be a point. And if it is a point, what do I know about tau value?
It will be
It will be 0. So,
0.
which means that it doesn't matter which direction I take. Since it is a point, it does not matter. Okay. And I'm able to extend it to 3-dimension. I call that as hydrostatic. Pseudo biaxial state can also be called pseudo hydrostatic because only 2 directions are taken. In a way, that also gives an idea to me as to how a pure normal stress condition would occur. Okay. Now, one more question. I want you people to think. Okay. There's no point in doing all this without us thinking. Supposing I have this, I have sigma 1 and sigma 2, but I know that sigma 1 is greater than 0 and sigma 2 is greater than 0. What can I tell about the state of stress? What can I tell about the stresses?
They would be the maximum minimum values.
This is maximum minimum values, correct. What else can I say? Think more, circle and answer.
They'll only have the stresses.
The diameter of most circle.
Diameter you can see. What's unique that you will see when this sigma 1 is greater than 0 as well as sigma 2 is greater than 0. Any other observation?
The circle will be to the right of tau axis.
And therefore, fantastic. And therefore, who said that? Yes, Janisha. And therefore,
No compressive stresses. Will always
no
be
compressive stresses. Put it in the positive framework instead of negative framework.
always tensile stresses.
Tensile.
Always tensile. So if I have something like this, it will always be tensile. We will call this as membrane stresses. Right? So this is a membrane. This is a membrane. I cannot apply a compressive stress. Right? It will just wrinkle. Right? Tensile stresses it can take. Right? In the uniaxial state, if it is only tensile stress, give me an example.
A rope.
A rope, a string, a cable, right? Now that's another thing that we know. All right. Okay. Most pressure vessels have very thin sheets that they are made of. All right. And therefore their ability to take compression is very low compared to tension. For all practical purposes, they assume that they cannot take compressive stresses. Okay, which automatically means that this is valid. Okay. For example, any questions so far? Is this clear to you? Okay. So for example, let's say this is part of a tube. Okay. There's a pipe. All right. I'm just showing a part of it. Now, both the mouths are open. Okay. But there is water flowing and therefore there is pressure. Okay. What will happen is this skin of the pressure vessel, will feel the pressure through its stresses. Correct? Yes or no? Okay. Now let's see whether we can seek to find out those stresses. Okay. If you are okay with this, we'll move to that. Okay. So let's focus on membrane stresses. Okay. Any other example of membrane stresses? The partying example.
Balloon.
Balloons, yes. All right. Balloons are pressure vessels and membrane stresses are basically acting. Okay. So if I have a cylindrical, so I'm just taking a part of a pipe. Okay. It's open. It's open. Okay. Because of the water flowing, right, there is pressure inside. So I'm going to draw that pressure over here like this. let's say P, and it is acting all through, okay? Pressure P, and I seek to find out the membrane stress, okay? Now, how would I go about doing this? So if I take the cross section is circular, and it is thin. So I'm just drawing a very thin like this. Okay. Let's say the diameter of this is D. Okay. So I can also say that the thickness is T, right? And I seek to find out, so it has pressure all over like this. Now I seek to find out what would be the membrane stresses in this. Okay. Now this being open along the longitudinal direction, what do you conclude? Is there any force in the longitudinal direction? Is there any force in the longitudinal direction?
Discuss first.
Just say yes or no here. There are only two answers.
Yeah.
Yeah, yes.
Are there longitudinal forces?
Yes.
Yes, sir.
What are the longitudinal forces?
That may be viscous forces acting in the boundary of.
Yeah. So assume that it is in the static condition.
In static condition or longitudinal forces.
There is no longitudinal, right?
No.
There is no longitudinal. So supposing I take a small element over here, right? That small element will be like this. Okay. This is the longitudinal direction, and this is the circumferential direction. Okay. So I have sigma circumferential. We also call that as hoop. Okay. So this is sigma hoop. And this is sigma longitudinal. Okay. Longi or longi doesn't matter. Longitudinal. All right. So one thing that I found out from here is straightforward. Sigma F, let's say this is X direction, this is Y direction, right? So sigma Fx is equal to 0 automatically gives me sigma longitudinal is equal to 0. All right. Now, how about sigma hoop? How will I find out the sigma hoop? How will I find out sigma hoop?
The pressure to be taken into account. And then,
Correct. Right. Yeah, go ahead.
then resolve the vectors and then equilibrium along the radial direction.
Okay. And then you will get it. Okay. Any other answer? Aditya, you've been keeping quiet. Hello. Aditya, are you
Yes, sir.
there?
Yes.
Yeah, yeah. One answer Sharad has given is okay. In this, I will resolve along the. He is saying radial direction.
Excuse me, sir.
Ah,
Sir, sir, I didn't understand which direction is sigma hoop. Like in cylindrical, it's rho cap,
so
theta cap, and z cap.
it is along the ring. It is along the ring. So if I take this is sigma L or longitudinal. This one, let me draw it with a different. So this is longitudinal. This that goes along the ring. So if I take the ring of this, it goes along this. This is sigma hoop. Okay. This is sigma longitudinal. Okay. Clear? Ayush? Yeah. How will I find out? By simple free body diagrams that I know of, how will I find out? One thing that I notice here, is it is uniform pressure that is applied, and the cylinder is axisymmetric. So number one, the structure that I have here is axisymmetric. Yes or no? Right? How about the loading? Loading is uniform irrespective of the angle that I take. So it is independent of the angle, right? Again, I can say that the loading on the structure is also axisymmetric. With these two, can I conclude about sigma hoop? What can I conclude about sigma hoop?
It would be the same everywhere.
It will also be axisymmetric. Sigma hoop is also axisymmetric. What do I mean by saying sigma hoop is axisymmetric? What do I mean by that?
Along the axis, it's all similar. Irrespective
Or
of the
in other
angle.
words, irrespective, exactly, irrespective of the angle that I take or orientation that I take of the diameter, the sigma hoop that I get will be the same. So it doesn't matter in what way I cut the structure. What's the simplest way that I can cut the structure and reveal the stresses? Because in order to reveal the stresses, I need to cut. What's the simplest way that I can cut?
Along the axis.
Along the axis, meaning make it a little bit.
Longitudinally.
Remember,
Longitudinally.
along the axis, see, I need to have a plane to cut. Is it not?
Oh.
Go ahead.
Sir, I didn't catch you.
I need to cut the structure so that the stress is revealed. What is the best way that I can cut?
Sir, draw a rectangle on a paper and superimpose it on the pipe and then cut.
Yeah, the pipe is there here.
Yes.
Now I need to fictitiously cut the pipe in order to reveal the hoop stress, sigma hoop. What is the best thing that I can do? Best way that I can go about? I'm asking a very, very simple question.
Remove a longitudinal strip along the length of the pipe.
One is longitudinal strip. Okay, so what you're saying is just cut like this and like this.
Yes, sir.
Okay, any other simpler way of applying the equilibrium equation? Any other simpler way?
Like a semicircular cylinder.
Oh my God, why did it take so much time here? I just have to cut like this. Why? Because the directions of the two revealed stresses will be the same. Correct? And therefore, I can take this. Remember, this is a cut portion, this is a cut portion, and pressure is acting like this. I can take one unit length here in this direction, right? This is pressure P. Having cut this, I will reveal stress times thickness, correct? So sigma hoop times thickness, correct? Here also sigma hoop times thickness. If I multiply this one unit also, I have multiplied by the area. So this is a force, this is a force. Okay. Now I can apply sigma along the y direction is equal to 0. Upward is positive. The pressure is acting upward. How will I find out the net force due to this pressure? That's very simple.
That area exposed, the rectangular E into 1.
The projected area, this means that P times
1 unit.
1 times
Thickness.
Into radius.
Sorry, the radius, 2 times the radius.
2 times the area.
times
So
of
in terms of diameter, right? This is the force upward, and the force downward would be
2
same
times
forces 2 times. You go ahead.
sigma h into T.
Okay. So is it possible? This is equal to 0, right? Because it's a static condition. This means what? Sigma hoop is equal to
PD by 2T.
I know the diameter, I know the pressure, I know the thickness, and therefore I can find out sigma hoop. So far, okay? Simple. Straightforward, right? So now tell me, supposing I close this. I close this. I close this. So where is that lid? I closed it now. I closed it now. It is closed here. It is closed here. Inside there is pressure. Let's solve that problem. What would be the main difference here? Will there be any difference on this, the cut that I have done?
No.
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 Okay. What else can I do now?
Longitudinal stress will develop.
Very good. Longitudinal stress will develop, and therefore, I need to make another cut in order to reveal sigma longitudinal. What would be the best cut that I can have?
Perpendicular to the axis.
Perpendicular to the axis. Fantastic. So I can take this. Let's say this is the closed side. I can take this. Right? And all along this, sigma longitudinal is acting. The area of this is thickness times
2 by r.
2 pi r or pi d, right? Right? So it's possible for me to find out this force. There is pressure acting in the other direction, correct? There is pressure in this direction. This is pressure P, right? So, and it is in the horizontal direction. This is the x direction. So sigma f x is equal to 0 implies sigma L times T times pi d. Help me out as far as the pressure is concerned.
P into pi r
P
square.
times
Pi r square.
pi r or pi d square
D
by
square by 4.
is equal to 0. Right? What do I get for sigma L?
Pi d by 4t.
Huh?
Pi d
Pi,
by 4t.
pi will go off.
Oh, PD by 4t.
PD by 4t. Yes. PD by 4t. Now tell me, this is sigma hoop. This is longitudinal. Which is higher?
Sigma hoop.
Sigma hoop is higher. Let us say, give me an example of a cylinder in which inside pressure is high. Give me an example.
Spray can, yeah, cylinder.
Come again?
Spray can, deodorant can.
Yeah, deodorant can. Very good.
Fire extinguisher.
Fire extinguisher. Very good.
LPG cylinder.
LPG cylinder, the essential part of LPG cylinder. There are so many of them, correct? Even the balloon, which is a long balloon, right? One more thing you've forgotten, Diwali is coming here. Diwali is approaching. A cylinder under pressure. Bindu, I cannot answer your chat message unless you come on video. Diwali is approaching. What is that kind of cylindrical? What do you fire?
Rockets, fireworks.
Rockets. What else here? The one that I was not expecting you would say, you are saying. What other? I mean, during Diwali you've been seeing, no? Vishnu cracker, okay, all those, right? So which are longish cylindrical, right? Let's say it is going to explode. Which one will dominate here? Sigma longitudinal or sigma hoop?
Sigma hoop.
Sigma hoop, right? Because sigma hoop is fast approaching the failure value compared to sigma this thing, and therefore, if it has to fail, will it fail as like this or like this? This is 1, this is 2. Will it split like this or will it
One.
1? Is it 1? Sigma hoop, you said, when it increases and goes to the failure limit, this happens. So if it has to explode, will it split? Will it split like this or will it split like this? You understood, no? Will it split like this and separate this way? Longitudinally, correct? That is why when you fire a Vishnu cracker, it explodes by throwing all the sheets of paper that it is made of, because it's just getting cut and it becomes now a pile of paper that is thrown out, not as 2 cylinders coming out. Got it? Is this clear? Right? So by simple understanding of this, it is possible for me to do the same. Okay. Quickly, if it is a spherical, pressure vessel, okay, with a thickness, okay, with a thickness T, okay, diameter D, I can do a similar exercise, right? Supposing, like Sharat said, I am now going to cut at the equator. Okay, I will expose similar to this. But now it will be a cap like this, correct? All over you have sigma, let's call that as meridian. So let's say this is meridian and this is, what shall we call this as? Let's say, I'm just going to call it as line of revolution. Okay. So sigma meridian, if I have to find out, it's very simple. Sigma meridian times, similar to what I have done over here, times pi d times T, right? And the pressure is similar to this, P times pi d squared by 4. So this is similar, which means I'll get this to be the expression for sigma meridian. So sigma meridian, for this, sigma meridian will be PD by 4T, correct? On the other hand, if I cut in the vertical plane,
Same.
it will be the same. Sigma, let's say R, I'm going to call it as R or rotational, okay? Revolution, sorry, is PD by 4T. Yeah, this is the cylindrical hoop and this is the spherical hoop. Now I'll ask the same question. Let's say firecracker, which is now spherical. Will it take more pressure compared to the Vishnu cracker?
Yes, sir.
The answer is twice. It will take twice before it fails.
Yeah.
And therefore, what do you expect in while if you fire Vishnu cracker or spherical cracker? Sriraj.
Spherical cracker will have twice the range of magnitude of explosion.
What magnitude?
Magnitude, like it will, the partial get thrown to a further range.
When a firecracker explodes, what do you feel? What do you get here? What is it that you receive apart from seeing?
Like,
sound, which will be louder sound?
Spherical.
Spherical.
Spherical. Name of a spherical cracker that you fire usually.
Bomb.
Sir, aloo bomb.
Atom bomb. Yes.
Atom bomb.
And that's why this sounds louder compared to this. May not be twice because there are other things associated with that, but that's the case as far as this is. In fact, if you increase the thickness, also the stress increases. If you reduce the diameter, again the stress decreases. Remember, apart from pressure, you have a diameter and the thickness coming into picture. If I want it to sound more, I can increase the thickness over here. Right? If I increase the thickness, the stress will come down. Right? Or I can decrease the diameter, make it very thin. And that is why if you go back and look at your air conditioner or fridge, the fluid that comes out of the compressor will have very thin tubes compared to the other section where it is again fed back to the compressor. What is going into the compressor and what is coming out of the compressor, there is a pressure difference. The pressure is higher when it comes out of the compressor. When it is going into the compressor, the pressure is lower. So I can afford to have a higher diameter pipe going into the compressor, but coming out of the compressor, I have to make sure that the stresses are brought down, which means I'll reduce the diameter. If I increase the thickness, then my cost of the material will go up. So the simplest thing I can do is I can reduce the diameter. Okay. So very simple understanding. If I have to reduce the stress, I have to either reduce the pressure, reduce the diameter, or increase the thickness. So simple as that. Or I should go for a different shape of the pressure vessel. One last question, any of you. An intelligent question will fetch you 3 marks. Only from the video on, people. No? Okay. If you don't have questions, I assume that you are either not understanding completely or you have understood everything. All right. Binary set only. Okay. Enjoy. Bye. See you tomorrow. Sandeep, you can, or Aditya, you can mark absent for those who have not put their video on for the groups that I have assigned. Don't do it today. From tomorrow onwards, you can do. Okay.
Sir,
Bye.
I think that list what you have sent in that WhatsApp,
Hmm.
I think
Hmm.
we don't have accessibility, right? I don't know.
Oh, okay. I'll give you the access. Okay. I'll give you the access. Okay. Thank you.